I'm Michael, and my research project is focusing on the chemical recycling of plastic waste, bringing this advanced technology into the public forum in a way that hasn't been done before. The main goals of this project are to educate the public about plastics and how to help them from becoming waste, to reduce the presence of plastic waste currently polluting local areas, and to support our transition into a circular economy by revamping the current recycling industry. A quick recap on the research that's been done so far. Mechanical recycling is the term used to describe what massive infrastructure like this does to plastic from your curbside recycling bin. The process has its limits, which means the plastic always ends up in landfill eventually anyway. Chemical recycling recycles the polymer chains at a chemical level, so plastic is able to retain its value. There are a number of companies around the world developing their own techniques to achieve this process, but all are running commercial scale operations or working towards it. This is fantastic, but it seems that public awareness of their goals is still fairly low, and their technology is not well understood. Especially in Australia, the subject of recycling seems to be surrounded by either confusion or false confidence. This is where my project firmly grounds itself. I began designing a small-scale recycling plant that in no way resembles the current recycling infrastructure, gearing the design towards a simple and approachable machine that takes the complexity out of the process. I hope to have it installed in public places where it can remain accessible to anyone that wants to learn more. The industry partner I have been working with is a Canadian startup called FYRP. They use microwave technology to heat and depolymerize polystyrene. My project shrinks their technology down into a smaller setup that can be safely placed in local communities to act as both an advanced plastic recycling centre as well as an interactive educational tool that provides people with easy to digest recycling information. The technology itself works in the same way that a kitchen microwave does, which relies on water molecules in your food that act like tiny magnets due to their slightly charged ends. The electromagnetic nature of the microwaves mean that each wave produces a tiny fluctuating electric field that flips these molecules back and forth very quickly, causing friction between neighbouring particles and heating them up. The same thing happens in plastic and allows this technology to heat up polymer chains to the point where they break down completely. With such a complex system of both established and developing technologies, many OEM parts will be sourced for the construction of the unit. However, to keep the aesthetic feeling warm and welcoming whilst maintaining an appropriate level of safety, an intelligent mix of timber, aluminium and steel will be used to fabricate most of the rest. The system will need to be operated by a trained supervisor, and to ensure safety, the equipment will be locked away after hours. However, the interactive screen will remain accessible 24/7 to promote consistent engagement. This partitioning of access will be made possible by an electrically powered fence that can act as a short barrier to keep viewers at a safe distance during operation, or a full-height wall that is impenetrable to any would-be vandals. There are a number of funding options available to assist in the development of recycling infrastructure in Victoria, as well as commercial grants like the ones offered by the Robert Bosch Foundation, who offer funding to projects tackling a broad range of global issues. Given the recent redesign of my unit, I need to get all of the parts that I'm designing into CAD in the next week or so that fine detail adjustments can be made and manufacturing processes can be confirmed. Prototyping for the fence mechanism also needs to be done that will ensure its resistance to damage and vandalism, given that it will be installed in a public place.